Hi there, how you doing?
Yeah, good, thanks. We'll just wait for a while. I've managed to do the one job that I was supposed to do, which is to record the
Hit
session. So
record.
yes, so I got that covered off.
How are you looking so awake, Dion?
It's only 10:30. It's not
Oh,
too
it's not
bad
too
yet.
bad. Not too bad.
No, and you guys in NHS Digital have got my whole body clock used to this thing now. Months of it.
Great presentation so far, everyone. Well done.
Yeah, thanks. I think that those last three were really interesting because it delves into sort of the practical where it all hits the real world, which is great. I just got a reminder from Helen to record. I've already done it, so that's great.
I'll just give it a few more minutes because people are still moving around.
Yeah.
I don't know how people are faring in other parts of the country, but it's still snowing in Yorkshire.
Wow.
You've got an amber warning for tomorrow, don't you?
I know, and the forecast says it's going to change to rain later in the day, so maybe it'll all get washed away. But then it's back again on the weekend by all accounts.
We got sunshine here, but it looks like you got sunshine there.
Well, it's currently 22.7 degrees.
Yeah, okay.
At 10:30 at night.
Mind you can get cold there.
Yeah, it can. I mean, we have a month a year where it gets below 10 degrees.
I think we have a couple where it gets above.
The hardest part, I think, is all our houses are really designed for summer, so we really feel that 1 month because we're not set up for it at all.
Yeah.
Well, we seem to have maybe stabilized a little bit. Do you think, Richard?
Yeah, let's crack on.
Maybe we should get started. Oh, Kate's reminding me of another chat thing to press the record button. Well, look, I guess this session was really to go through probably what's of interest to everybody on the call, not too much sort of structured presentation from us. I've got some things that I can show you through to give you more of an idea of how the Fire API works and the things that are important in the interoperability space, I suppose. And I don't know if there's specific things you wanted to talk about, Richard, but there's a bunch of experience you've got there, obviously, from your presentation, which is where it gets difficult and how to deal with the difficult things, particularly. So I guess before we get started, was there anything anybody in particular wanted to see or to cover off?
Yeah, just one thing I'd like us to talk about briefly is the need to persist. So, you know, versus just lookup and mapping. Your incoming data is going to be coded. If your incoming data is coded and you're translating or mapping, the need to map to persist what you've looked up, or from a provenance point of view, just some thoughts around that.
Yeah, absolutely. And I think that whole concept, and again, you know, I'd probably defer to Richard, who's got a lot more experience than me in this space, but certainly the specifications and standards, and the ones that we had in Australia at least as well, also very much encourage you to keep the original data, so that the translations or things that go along with it are things that go along the side of the data. They don't replace the original data. And there are places to record the provenance of the original data, as well as the translated pieces of information. The richness of how that's recorded and the specific map that was used and that sort of thing is maybe, I don't know whether there's a great deal of maturity around that in FHIR as to how that's actually rendered out at the moment. But Richard, do you have experiences with that? Because I know that that's sort of a topic that's
So one of the things that we do is, so our sort of new data architecture has a number of different sort of clinical data stores. So, for example, we may have one that handles, I say, diagnosis information. Now, sometimes we will get data coming in and it will be coded in either a legacy terminology, read CTV3 over here in England, or maybe a customer's own local coding scheme, which we understand enough to map out of into StoMed. Or sometimes there's just no code at all. You know, we get a diagnosis and it's just a text field and there with some string in it, but we do know it's a diagnosis. So what we do is we attach metadata to the record, you know, and we do clearly preserve what was sent to us. We record as metadata how we translated it. And what we're doing in a moment, and I briefly mentioned this before, is in the absence of anything else, we're using the ontology of the SnoMed semantic tags as just labels to put on data, so that we can then say, you know, where you know, if it's a diagnosis, had this had a SnoMed code, this is where it would have gone. You know, so it's very broad, but it does then allow us to, you know, so for example, for us, we have one clinical store which will have procedures, diagnoses, observations, all sorts of different things in there. So when someone comes along and says, I want, so say we were doing a FHIR query, and we were doing the FHIR query and it was looking for, you know, conditions or findings, then we only want to return things that are conditions or findings, even if they don't have a code. You know, so that's what we do. We, as it comes into the organization, by whatever means it comes in, we will do our best to, you know, annotate it with various types of metadata to support that. And then it also helps in query mechanisms as well, where we can, you know, tune our database queries, servicing, you know, the API calls to make them more efficient.
Yeah, there's also that that question of, you know, when you're kind of enriching data through some sort of translation from a map, or as you said in your presentation, pulling even data in from the terminology into some other sort of store to enrich some data. There's a tension there between doing that and deferring that until you actually need to make that query of the data, so that in effect, if you're using a particular map and translating content into that, you're kind of casting the context of that map and the point in time that map existed into that,
yeah, for sure,
data, which may be may be perfectly fine for the use case, or it might be better to defer that to later.
Yeah,
as
I mean, it's definitely a trade-off. You know, it's a trade-off between when you load data and you tend to not be as time pressured, versus when you're querying data and you're incredibly time pressured. You know, so our, you know, depending which sort of subsystem it is, but some of our subsystems are you know, operating at tens of thousands of queries per minute. You know, you haven't got time to be doing an awful lot, you know, so and you know, so it's a trade-off between the semanticness, correctness of it all, the operational performance of it all, and you know, and a lot of experimenting at the moment.
Yeah, absolutely. Was there anybody else who had anything that you'd like to talk through, or questions you particularly wanted answered?
Yeah, I was sort of interested in the data quality and the pulling together of data, and if you had any good news stories, hints as to how you actually convince, as I think it was Carl said before, the ordinary people need to understand this. I would classify the ordinary people who don't actually understand the importance of data in its full context. Have you got any? So it'd be, I'm sort of dealing with the data in Northern Ireland, so we've got Read 2, CVT3. We're working through all of these combinations of pulling data from all the different sources together, and it's really getting people to take data quality and the information as importantly as it seems to be required to give information and analysis back to people. So
for us, I mean, it's something which we're only at sort of the beginning of the journey, so to speak, but we are getting acknowledgement from, you know, our customers who, you know, capture the data in the first place, but actually they need to improve, and that's because I think people are asking more of data than they ever have done in the past. So it certainly was the case, you know, several years ago when, you know, customers were sending data to us, but the only real use case of that data was to put it on a screen, so that you could share it across a community and other people could have a look at that data and see what's the holistic, you know, care record for, you know, across different organizational boundaries. But the world's moved on, and the world's moved on quite rapidly, and actually I think, you know, there's a perverse incentive of COVID because it's really driven things on at a vast rate of knots. So people are asking now questions like, well, actually, if we're getting data that's moving around the system, how do I make sure I'm not getting duplicated data? And, you know, and having, you know, more precision in your data and more data quality in your data give you more vectors to duplicate it by, and be assured of uniqueness. Because things will get transformed as we move between system and system, you know. So for example, one of the use cases that we're working on at the moment is you may get pathology results coming out of an acute hospital, and those acute hospitals, now some acute hospitals share those with ourselves, but they'll also share them with the GP when the GP shares them with ourselves. You know, and there's all sorts of mungingness goes on as it moves around the system. But how do we make sure that when we represent it in the system, we're only showing that data once, even though it's come from different sources using different terminologies, you know, so, and it's a challenge, but the more precision you put in with data, the more structured you put your data and the more quality of that you put in your data, then you can achieve better results. We're getting more in, you know, around not just being able to display data, but doing decision, you know, making decisions on that data, and, you know, to safely make those decisions on the data. And it requires more quality in the data. You need to have a higher degree of trust in that data, so that you can, you know, have more assured outcomes. But the most important thing that's driving it in a moment is analytics. And as much as analytics can deal with a little bit of noise in there, when you're looking for sort of micro populations within there, you know, so you're looking in a big cohort of patients to find a small subpopulation who have certain characteristics, but actually the quality becomes important. And, you know, and we're seeing that more and more value and And that's probably the single thing at the moment which is driving our customers to seriously take a look at their data quality. In fact, they're actually understanding there's value in it now. And a bit like Charles was saying earlier, when you have a discussion with the clinicians who realize that the recording of the data is not about just that immediate caregiving process that's going on, but actually the downstream benefits that you can get on being able to analyze that data and improve healthcare as a consequence, that's beginning to emerge. It's going to be a journey. It's not going to change overnight, but I think it's small steps.
I think certainly, I guess most of my experiences from Australia working for the Digital Health Agency here, and I suppose we've sort of been on a bit of a journey through. It depends, different in different sectors, but through from effectively free text entry, changing into sort of coded entries or controlled vocabularies. And generally speaking, the willingness is actually there from the clinicians that are involved in this. It often, for us, the experiences where it's been let down is in the implementation of the actual user interfaces and things that they interact with, and the implementation of the terminology in those systems anyway. And so I think the emergency department experience we had was probably most pertinent in that we've moved from a position where there was a bunch of free text stuff going on through to using sort of SNOMED coded data in particular places. However, they initially moved to using effectively just the first implementation, which was horrid many years ago, effectively just let someone search all of SNOMED, and they were presented back a list of options to pick, which was matching sort of descriptions that were then alphabetically sorted. So it was almost impossible for them to find what they wanted out of that, and they got frustrated and just put in whatever because they needed this thing to go away. There was kind of a counter reaction to that, which was then to try and slim down to this really constrained set of codes, like maybe about 2,000 problem diagnosis codes. And of course, that was counter to the quality needs as well, because we found that clinicians then had to often select, and I mean, it was further than that at first. It was down to only like 1,000 or so, where they would be picking something and then having to put in the free text field all of the rest of the information that code was just way too coarse to cover. And ultimately, the answer is to use quite broad selections out of, like, say, SNOMED CT, but defining the terminology binding for that particular element to be able to define what are the things that semantically fit in this position. We're not limiting the person on what they can select out of SNOMED we're only limiting them to the relevant part, but out of the relevant part, they can be as specific as they like. And that's kind of easier said than done, actually. It's not. It's defining those bindings can be pretty complicated. But that combined with the sort of high quality search, type-head search based interfaces gives people the ability to pretty much say what they want and to pick what they want with a much higher accuracy. And so the quality of data has ultimately improved to something that was frankly probably better as free text originally, and then the coded things in between were probably inferior because of the constraints that existed in them, and then ultimately back to something that's far better. I think I saw Kylene was here before, and she's gone now, but another one, I know we were talking before about penicillin. Donna's favorite is hypercholesterolemia, which she's seen in the mappings that she's done spelled, I don't know, something upward of 200 ways, because it's not easy to spell and type, and fat fingers and all of that kind of thing. So yeah, look, I mean, I can show you another thing to think about. If I show you this, I don't know whether people have seen this before, but it gives you the idea. Can you see the Snowman
Yeah,
search
I can
demo.
see it. Yeah.
Yeah, so this is really just using that search. So I can type in here, you know, and I'm getting immediate responses from the server, and I can type in things like heart attack and get myocardial infarction. So that's matching on the synonym, not just on the on all of the preferred terms. But it's also giving me back. It isn't giving me back multiple descriptions, like all of the descriptions associated with myocardial infarction, which there would be heart attack and a bunch of others. So I'm picking a concept. So it's making me say, yes, yeah, that's actually kind of what I meant. Doing these things like there's a, if I want to search for hypercholesterolemia, that's not necessarily easy to get to. This particular widget is actually allows us to do a thing which is called boosting. So I can say, I can still let someone pick all of the content out of the bound set for that element. So anything that's relevant in that element, but I can boost up things that are much more common to be used in this particular setting, for example, so that those search results float to the top. So I can easily get, you know, hypercholesterolemia. And all sorts of other things, like if I pick on a procedure that is, you know, I can have a you know, frontal lobe biopsy, and I've got laterality has been turned off here. Whereas if I have lung lobe, I now have that enabled, and because it knows that this particular concept is lateralizable. So there's a bunch of stuff that can be done, and this is really the topic of the other group, that can be done to make data entry much more accurate and actually much faster for the person doing the data entry, if it's done, you know, done well. And this is all just leaning on the terminology server. Can work with Snowstorm, which is Snowman International server as well. This is just all of that functionality is just using the Fire API to do all
Dion?
of that. Yeah.
What's doing the boost then? Is that the terminology server or is that the local server?
This particular implementation of Boost, because it supports Snowstorm as well, it's actually happening on the client side. So what it's doing is searching between two different value sets and then applying the Boost client side. Ondo Server's actually got a Boost feature that Snowstorm doesn't have. That's why it's had to be done on the client side. That you can it'll do all that server side for you and just give you back a different ranking essentially.
Sure.
Yeah, so yeah, that kind of stuff is, you know, is useful to know that it exists, and to go and play with these sorts of demonstrators and things to understand what's possible, and how to use the API for developers. That's great. You can open up the developer console and see exactly how that application's doing what it's doing. And honestly, it's not that complicated. It's just a few REST requests.
I've got a question. It's more kind of application oriented. Richard earlier on talked about this nirvana of application config using terminology rather than in code, and that's something that I'm trying to move towards. And an example might be so I'm involved with the National Pathology Exchange. So we're moving requests and results between different trusts in the UK primarily. As an example, we might get a local specimen code, a local test code for white cell count, for example, but on which is fairly easy as a requestable. It will go from this lab to that lab, but there might be examples where, say, if the specimen type is blood, it goes to lab A, but if the specimen type is serum, then it would go to lab B. So you get this kind of almost a hierarchical approach to what the application needs to do based on various contents of the message. And I've achieved this before in previous roles using CTS version 1 type models, but only up to a point. You kind of get into this 3-body problem where you can never quite work out what happens next. And I was just wondering if there's any experience of that kind of approach using Onto Server, very much more real time rather than here's a result, we need to turn it into something that's clinically consistent so that we can then share it or analyze it. I'm thinking more about how can we use this approach to control where a message is being routed or how it's being handled. Just wondering if anyone's got any experience or thoughts on that.
Just a side thought, from a safety perspective, I would imagine that is something that would worry you.
Yeah, absolutely. I mean, the more it can be managed as almost a separate entity, so that those control mechanisms are not written by a developer, they're actually encoded formally, and then an application just does what it's being told to do by an external system, is obviously a much safer approach. But the upfront infrastructure investment, if you like, is a lot greater.
Yeah, look.
So,
sorry.
so
Richard.
I was going to say, so not quite the same thing what you look at, and some of the things that we experimented on and then put down, not because it wasn't necessarily working, we just have other priorities, is to start. So in terminology, you can attach different properties to codes. So it's not just the code and the display and a code system. You can define, you can define your own properties on things. Now we were doing various different experiments, and I say we didn't really conclude. But two of the things that we tried were, so say we had some codes which had some extra value in them, and we wanted to do things on receipt of those codes. We would take those codes and, somewhat naughtily change the code system on them. So even so we had 100 SNOMED codes that were of interest. We could either put them in the value set and then see whether they're in the value set, or we could actually create our own code system with those 100 codes in. And then when we're doing those decisions, we just change the code system, say it's something else. And then we can define a bunch of additional properties on there, and then they can be anything you want. Or we can use value set supplements, and which is basically allows you to overlay properties on an existing code system, which is a bit volatile at the moment in the world of SNOMED and Fire and whatever, which is kind of where I suspect we will end up in the future, but we don't really want to go down that path and then it all change under our feet. So there's lots of different things you can do. I guess it comes down to how complicated these different dimensions you have are and how frequently they're going to change. So for things which are relatively stable, then I would kind of potentially look towards using properties of a terminology, which a terminology server will help you with, because remember you can filter on these properties as well. So there's other things that you can do with them. But if it's going to be somewhat more dynamic and these can change fairly frequently, it's possibly not an approach I'd take.
Okay, thanks. That's interesting, because certainly in CTS version 1, properties was a key component that certainly I made a lot of use of, and it hasn't been as obvious to me that exists in the Fire terminology model. So it's heartening to know. And I guess the next step is almost properties of relationships, if you like, which is doable, because a relationship is just a concept. But then you have to have the properties changing depending on the specific mapping that you're talking about.
Yeah. So you have in Fire, so code systems. So code systems, as Richard said, have properties. you can also have, so for every code, and then onto server supports having code system supplements, which are effectively like that overlay. So you can define for any pre-existing code system, you can define a supplement which overlays additional properties and basically annotates all of the concepts you define with these different additional properties. I guess the other tool in the sort of tool chest is concept map. And concept map, I guess concept map, unlike code system and value set, which are now normative, concept maps a lot lower maturity. However, it does have the ability to be able to define the relationship between two concepts. So whether one is, equivalent to the other or narrow or broader in the context of the map. It can also define very fuzzy things that these two things are related to each other. But it can also define these sort of depends on semantics. So you can say that this map only holds true under these other conditions. And so you can actually provide sort of multiple inputs into the map, if you like, to say, I want to know what this code translates to into this other code system with these other couple of properties, and then get back an answer. So there are ways you could sort of represent the kind of data you're talking about in those structures. Whether that's the most appropriate thing to do, I'm not sure, given the circumstances, but yeah, definitely you can do that kind of thing.
Great, thank you. There's some interesting leads there. Cheers.
I get the distinct feeling, though, that based on what I've heard so far and what I've seen, is the idea of automating the ontology conversion, so in an interoperability scenario, versus a human interaction, where the human is interacting with the UI and they're given the opportunity to determine what looks right, versus getting it a program to determine what is right. I mean, doing pure mapping is fine. However, from what I've seen, there seems to be a lot of intelligence in terms of trying to query the terminology server or services. It appears as though you could get into a situation where there's a complex related number of decisions to be made to try and drill down into a complex space.
Yeah, this is very much in the space of so there's the SNOMED International publishes complex type maps between SNOMED and ICD, and those things, and I believe NHS Digital also sort of publish their own or augment those. And really they're trying to represent and the data required and the rules required to effectively assist clinical coders in correctly coding something in ICD and the classification, which is a complicated task because the classification is often talking about additional things that might exist in the record well outside the SNOMED code itself, and the age of the patient and a bunch of other things. But I guess not all mapping happens in that particular context. So one of the examples we have that happens in emergency department in Australia is there's a bunch of mapping that happens for funding reimbursement purposes. It actually goes into ICD, but it's for a reimbursement purpose, and it is actually a direct translation of the diagnosis, which is perfect for a kind of a one-to-one generated map that's actually generated through automation assistance for humans that create the map. And then once the map's created, the actual use of the map is completely automated. So it really depends on the purpose of why you're translating the data, the nature of the source and target, and obviously a terminology and a classification is probably going to be the most tortured. You know, the purpose and context of why you're doing that. Analytics is another really good example as well, is where you could actually have quite a lot of skew or particular skew or losses in the mapping that you've got, which is perfectly fine in the use case that you've got for the analysis of the data. It may not be appropriate clinically, as an example.
I think for Andy's use case, you know, the fact that you've got validated maps, and I'm sure there'd be clinical involvement in ensuring that the maps fit the use cases. Yes. But you know, to get it, I mean, getting AI into this and getting AI to do this, I think is an interesting problem. Oh.
Yeah, I think that again, that maps are really expensive, particularly, you know, the ones that have to be maintained by humans and highly validated and that kind of thing. They're very expensive things to maintain and own. But then, you know, obviously, if there's high enough value in translating the content, then it's worth the cost of the map. And the cost really varies depending upon you know, the purpose of the map, the accuracy level required, that kind of thing. So the terminology server, it does have some features that are useful for maintaining maps or making the map in the first place and maintaining maps. So it has kind of an auto map translate function, which is basically just trying to give you suggestions based on your input codes, what suggested targets you might have, just to ease the burden on the person doing the manual map. Has some additional features for things like SNOMED, where SNOMED, when it retires a code, will reference the replacement codes or possible replacement codes for that, and that gets used to make it easier for the person doing the mapping by the tool being able to say, oh, you probably want to change the mapping to one of these two things. But in the end, the human's still involved in that process. Otherwise, the terminology server really is just hosting the map that someone else has created for the use by systems to translate content. Well, if there's no other questions immediately, maybe I can, and if there are, I'll pause for a moment. Is there anybody else?
Yes.
Yeah.
Sorry, I had one which
sure.
I appreciate we're probably running short of time, but I'm in a slightly different position with this, where I'm actually sort of right at the beginning of defining an interoperability scenario within a specific discipline. I'm creating FHIR profiles like structure definitions, which will have to include, you know, references to value sets, and hopefully, in our case, there'll be relatively constrained value sets with small numbers of codes in that are relevant to the specific discipline that we're working in, and the specific context, you know, that these resources are going to be used in at the moment. Anyway, I just wondered if you had any recommendations about the approach to take at that stage of FHIR profiling and defining value sets, and what the best ways of doing that. And obviously, we've got a choice between I'm just literally creating a value set with a list of SNOMED codes in it, or using ECL expressions or some other method for defining those, or, you know, or using existing reference sets where they exist, or possibly creating our own SNOMED namespace and defining our own reference sets in that. I just wonder what are the pros and cons of each of those, or what are the, you know, what in general, any other general advice you have about FHIR profiling and defining value sets in profiles.
So I've had a bit of experience with this, again, working for the Digital Health Agency in Australia, where we've, you know, worked on a bunch of this. We started out with wherever we were working with SNOMED. I mean, we had the old style was before Fire. We had reference sets defined in SNOMED CT, and that was how you defined a set of SNOMED CT codes that were bound to typically a CDA specification for us. Obviously, all of those transfer over then into being implicit value sets in Fire, and that's sort of initially the way we continued. Ultimately, that sort of changed because under the hood, we're really defining those values or those reference sets using ECL anyway. So over time, it became more practical to actually define those as value sets that we defined with ECL expressions, and then bound the profiles to reference those particular value sets. There was talk of using implicit value set references using ECL in the profile specifications themselves. So not having the explicit value set. I think that the benefit of having the explicit value set in between is you get to sort of version that and have it change and sort of decouple the profile specification from the changes to the underlying terminology. So it gives you another place to kind of configure that binding. So we definitely didn't do that. We went down that path of having an explicit value set in between, which gave us that flexibility to define and modify that over time. We actually went down a semantic versioning approach with that as well, so that the specification, the profile, referenced the value set in a kind of a major version specific way. And then we had these rules defining, and this gets really tricky, defining what would be a major change to that value set. And then that caused effectively a URI change, which caused the profile to need to be updated to actually reference the new major version of that value set. But we allowed ourselves the ability to modify that in minor ways to say that it was still forward compatible. I guess the other consideration then is to say, you know, how many places are you going to reference this one value set from, and how many profiles and how many specs? Because the more places that use it, the more care is required if it does actually need to get updated. So there's a bunch of different trade-offs there. But I guess ultimately, probably if you can go down the ECL type approach, one level it makes it easier to maintain the content. On another level, it means you actually need to make sure you keep checking it, because expanding that against a different version of SNOMED is potentially going to change. That might be a good thing. It might be a bad thing.
I think it's a trade-off between making this as future-proof as possible, but also accommodating the constraints that we're working with our existing systems. Right now, we're dealing with, you know, quite short pick lists, which is what actually our end users actually really prefer in most situations. There are obviously situations where we do have searchable, you know, terminology fields and so on. But generally, the users prefer to work day-to-day, prefer to work with just a simple list of you know, a short number of options to pick from when they're kind of like tapping through the screens and so on. So I think it's the trade-off between like still enabling that versus making the whole thing a bit more future-proof and open-ended. So there's always going to be trade-offs there. But it's I take what you're saying about decoupling as being a good idea. We're also working in the context of a sort of a national reference model as well for these data items, and to a certain extent the codings associated with them as well. So that's another factor that comes in, you know, and they have defined in that some ECL expressions for codings, but some of those are quite specific. Some of them are really open-ended. So you know, it's quite a mixed environment that we're working in as well. I think in the short term, we're going to need to keep sort of quite tight control over the codings, but I don't want to limit that in the long term. So I think what you're saying about decoupling makes sense.
Yeah, I mean, you can obviously change the value set definition over time. So you could start with a
Yeah.
generated list, and then in future versions, you could expand it out if that became appropriate. I think that there's also, obviously a value set can be defined in terms of other value sets. So if you,
Yes.
if you want to use a value set that's from from somebody else, and you can bind directly to it, then if you've got a high level of trust in them and that value set and the future, then that can work. If you've got a low level of trust but you still want to use it, you can sort of effectively wrapper that by defining your value set in terms of their value set, and then applying constraints and things on top of that.
Yeah.
And that can be a way of sort of trying to insulate yourself. But certainly the terminology server is also a really useful way of doing the sorts of validation checking that happens when you've got a new version. So we actually wrote expansion requests that would expand a value set. It would basically expand, because you can expand by posting a value set definition to the server to say, I want you to expand this value set that you don't know about, and here it is,
Yeah.
and expand it for me. You can define that in terms of the value set that you're interested in, expanding that value set between two different versions of the underlying code system, and then finding the intersection between those and the disjunction between those, and saying, and that can tell you how that value set's actually changed between multiple versions of the underlying code system, to give you a heads up as to whether you need to do anything or not.
So you could even be actively testing against that. You could have, define whatever unit tests or integration tests against that kind of thing.
Yeah, we set up automation for that, so that what it did was just highlighted to the human people that we had looking after these bindings, these are the things you need to go and have a look at, because there's something's changed. Maybe it's good, maybe it's bad, the computer doesn't know. But it's highlighting those to a human, you should go and check these because the terminology's changed, and therefore the value set expansion has changed as a result.
Yeah. Thanks, that's really, really helpful. Thank you.
Yeah, no worries. Yeah.
I've got a lot to learn about this, but that's my dipping the toe into the water a wee bit. Thank you.
Yeah, that's all right. I mean, there's a lot of stuff. I've been encouraging the Digital Health Agency actually to publish their, and we're getting close to it, their value set, particularly value sets, but other code systems and things as well. But they came up with a effectively naming identification versioning scheme for how, what they set their URIs to, what they set their ID to when they create these resources, what they set the name to, what the version is, how the version changes, that kind of thing. And there's a number of opinionated decisions in there, and some of them were kind of difficult to come to a decision. But even some of the toing and froing about when it's good to choose one thing versus the other is actually useful. And I'm trying to encourage them to publish that document to say, for other people to look at who may not choose to adopt the exact same scheme, but it's got a bunch of things that are worth thinking about when you do that for yourself.
Yeah, it'd be interesting to see that. Yeah.
I'll keep on them.
Thanks very much. Thank you.
No worries. I don't actually know.
So,
how
Dion,
much longer we've
could
got.
I ask possibly
Sure.
regarding local or regional or local terminology servers setups, and perhaps even local terminology services for application-specific implementations? Do you have any ideas about how it will progress in terms of a number of instances in various locations, and will that be kind of managed in some way, or do you have any regional or local setups planned right now?
So I suppose there's NHS Digital and
Yes.
Wales obviously have their own deployment. Wales are using that for a specific application that was the topic of that conversation or the presentation earlier. Aside from that, there's nothing sort of specific yet. I mean, it's really up to whoever finds such a thing useful. There's obviously outside of other sort of commercial operations, but I think really it comes down to, and I guess this comes back to probably somewhere my experience in Australia can kind of colour a little bit what may happen. In Australia is a little bit different because we actually made the licenses under the agreement signed with the Digital Health Agency, and whatever it became, onto-server licenses became free for use in Australian healthcare. But then also there was no hosted option as well, which was also a bit of an impediment actually, because some people the hassle of setting it all up has proven to be a bit difficult. But I think that there's about 70, 80 license holders in Australia of onto-server licenses, and there's a bunch of those are the state health jurisdictions. Some of them have a number of instances, some of them have got sort of these central sort of instances, and then a bunch of different projects and organizations. The main reason that they have them, the main reasons, I suppose I should say, that they don't just use the national terminology server, which they absolutely could or can, is that the national terminology server in Australia is not warranted for kind of runtime use. There's no SLA given, there's no high availability given, or guarantees, I suppose, given that it is actually quite performant and quite available, but there's no guarantees, there's no SLAs. And the content changes when the content changes. When the national provider, they say when it's going to change, but it happens when they want. There's no control for local people to say, oh no, don't change it yet. And there's no additional content, it's only the national content that's in it. So really the main reason people run their own is when they want to control when they get the updates, control the, meet some particular performance requirement or SLA, and be able to fundamentally be able to populate it with their own content. And there's quite a lot of that. For being able to add in their own local code sets and then maps to the national codes and all of that kind of thing.
Mm-hmm. Great. I guess we'll ask Richard as well. I suppose Richard would be one of the first in line to get his own instance.